What is up, people? We're going to be on page 190 to start. We'll go to 191. So we're going to be writing some functions from graphs. This first example, we've got this plan for a skateboard ramp, and it says for every 9 inches of height, the triangle should have a base that is 33 inches long. So what is the height of the ramp shown? So down here, they've already graphed it for us, which is always nice. So they took that point 933, or sorry, 33.9, and what they did was they found the slope. Okay, so between 0, 0 and this, it went up 9, so that's our change in y, which is 9 over, and then we go over 33. So our slope would be 9 over 33, which simplifies to 3 over 11. So they just basically did, rise over run here to find our slope. Okay? Or they change, we also say change in y over change in x. All right? So you could use either one of those to find the slope there. So then they took that and they plugged it into an equation. So our equations always look the same, at least for now. Y equals mx plus b, where m, just as a reminder, is our slope, and b is our y-intercept. Okay? And on this one, our plus b, our y-intercept, well, it crosses at 0. Okay? So we're not going to have a y-intercept. We don't write plus 0 at the end because adding 0 doesn't change anything. So all we're going to do is we're going to take our slope and just plug it in where m is. So that's why the equation is y equals 3 over 11x. Okay? So then, since x represents our base length, and that's 110 inches, all we have to do is take 110 and plug it in the x position. So we do 3/11 times 110, and we figure out that the height of this ramp should be 30 inches. Okay? So you find the slope, you plug it in to where m is in the equation, you have a plus b sometimes. So what I'm going to have you guys do now is do the try it down here on page 190. This one down here. So how will the height of the ramp change if the plans show, or if the plan shows that for every 3 inches of height, the triangle should have a base that is 15 inches long? So I'll help you get started on this one. What I would do is maybe make a little table and start with our x, which from before this we know that the base is our x, or it says right here base length is our x values, and then our y values are the height. Okay, so just start plugging in some numbers over here. Maybe just do 0, 10, 20, and 30. And then we know that for every 3 inches of height, the triangle should have a base that is 15 inches long. So we do change in y, so 3 over 15. So it should come out to about 1/5. So then in our equation, we would have y equals 1/5 x. And then you can just use that. So then take your x values, plug them in. Well, 1/5 of 0 is just 0. 1/5 of 10 is 2. 1/5 of 20 is 4. And 1/5 of 30 is 6. All right, and then you guys plot those points. And then tell me if the base length is 110 inches, then the height of the ramp will be this many inches. So you guys go ahead and tell me that. All right, and then we're on to the next page, example 2. So, in this one, the cost to manufacture some toys is $5 for, or $17.50 for 5 toys, and then $30 for 10 toys. So it says construct a linear function in the form of y equals mx plus b. And the way that we do that is this. So over here, I'm just going to write the formula. So it should look pretty familiar. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, that's all that this is right here. Okay, so they took this first point of 5/1750 and they labeled it as x1 and y sub 1. And then they took the second point, which is 10 toys for $30, and they called that x sub 2 and y sub 2. And so now they're just putting it into this formula. So you can see right here, they're taking y sub 2 minus their y sub 1 over their x sub 2 minus their x sub 1, and they get this 12.5 over 5, or 2.5 every 1. So that means that our equation would have to start with y equals 2.5x. All right, because we know that 2.5 is the slope. So now it says use the slope and one set of the values for x and y to find the y-intercept. So here's what they're doing here. I'm going to show it over here. They're saying y equals 2.5x plus b, right? We don't know the y-intercept yet, but we can figure it out. I'm going to use the 10 and the 30 because they're whole numbers, okay? Remember how I said 10 was an x value? Well, that means I can put it in here for x. I wouldn't put x there. I'd put what x equals, which is 10. And then I still have this plus b at the end. And then my y value that's associated with my x value of 10 is 30. So I'm going to put a 30 over here, and I'm going to solve this equation. So I'll do a little bit of simplifying. So I'd say 30 equals 2.5 times 10 is 25, and then plus b. And then all I have to do is subtract this 25 from both sides. So 30 minus 25 is 5, so we get b. So b equals 5. So on our equation up over here, I know that I have to add a plus 5. And when we're talking about like toys or creating toys or whatever, maybe that plus b is like the materials or something like that to build those toys, okay? So that's how they came up with the b. So our final equation, y equals 2.5x plus 5. All right, then you guys are going to try it here. We've got Jin is tracking how much food he feeds his dogs each week. After 2 weeks, he has 8.5 cups of dog food. After 5 weeks, he has 21.25 cups. So you're going to use those. You're going to say our point 8.5, comma, after 2 weeks, oh, shoot, I flipped that. So you're going to have 2, comma, 8.5, because after 2 weeks, he has 8.5 pounds of food. And then after 5 weeks, he has 21.25, which is 21.25. Okay? So you guys are going to plug that in, find with the slope formula, find the rate of change or the unit rate, which then you'll put in for m. Then you'll choose one of these points like we did here, plug them in for x and y, and then solve for b. Try that. I know that's a lot of work going into that one. All right? And then we're going to go down to number 3. So interpret a function from a graph. So the graph shows the relationship of the height of a candle burning over time. What function represents the relationship? So we want to write it as y equals mx plus b. Okay? So in this case, we're burning a candle. Okay? So when I look at this line, I'm thinking this point where it crosses the y-intercept, our plus b, is where it starts, right? So I'm going to have a plus 10 at the end. And then my y, my equals, and my x all go in the same spots. But then I have to look at kind of what's happening. I know that as a candle burns, it's going to get shorter, right? So the height of the candle is going to be going down as the time goes on. So I just have to figure out how much does it go down. And that's when I find those perfect points, right? We practiced this on our delta math the other day, and we do rise over run. So since this goes down 1, I would actually call this negative 1, and then right 1, which is positive 1. So I would have negative 1 over 1, which is just negative 1. So my rate of change is negative 1. So that's why I would put a negative 1 there. And that makes sense because it's losing height. It's going down. Okay? All right. So then the last thing I want you guys to try is this try it down here. So the graph shows the relationship between the number of pages printed by a printer and the warm-up time before each printing. What function in the form of y equals mx plus b represents this relationship? So you guys are going to have to find your y-intercept, plug that in for b. You're going to have to use rise over run to figure out your m, and then you should be good. All right, guys, thanks for watching.